Don't forget you're working on your seating chart. And if you're on Zoom, make sure that you put your name down here. Still got about 3 more minutes. Try. Oh, that's much better. It automatically goes back to mine. What happens when I trade? Always go back to that. I want it to be thin because I feel like it's so thick when I write, but apparently it's a little harder to do than I thought. That's okay. Save that? No, see it goes back. Okay. All right. So remember I messed up the joke last time. Remember this? So I said, what do you get when you cross a parrot and a centipede? A walkie-talkie. Walkie-talkie. I feel so bad. I totally blanked on it. I remembered it by the time 5T rolled around, but all right, so I got a better one for you. What did one eye say to the other eye? Just between you and me, something smells. Takes a little while for that one to sink in. All right. So we are starting chapter 3 today. So normally, what were you supposed to have done before you walked in the door today? Because we're starting chapter 3 today. You were supposed to have watched the recorded lectures for chapter 3, sections 1, 2, and 3. Yeah. So normally I would have some iClicker questions that cover what I covered in the lecture to make sure that you watch the lecture, right? But I know it's kind of a hard time right now. So today is the last day of no iClicker questions. Starting on Tuesday, it will be daily, not daily because you don't see me every day, but every class period, iClicker questions, okay? So I know we're all trying to get back into the habit and back into the swing of things, but you need to come to class having watched those videos, okay? Good? Yeah? All right, let's see. What else? Oh, I posted your exam grades on Moodle. They were really good. They were really good. So I do not have the grades released yet on the Pearson site. The Pearson site is having some issues, but eventually it will be. And when I do, I'll send you a message through Moodle, just like I did on the grades. Did everybody get that notification? If you didn't get that notification, there's something wrong with your notification settings and you need to fix it. All right, let's see. And that's it. Okay, everybody did their seating chart, correct? And if you're on Zoom, make sure you put your name there on Zoom. Okay. So let's go ahead and get started. All right, so chapter three is all about how elements combine. Oh, and this was my reminder. What should you have out right now? Your periodic table, really your best friend, right? Your best friend's got a lot of stuff on it. So make sure your best friend is out today. You are going to use your best friend a ton today. So please make sure you have it out. Okay. All right. So chapter 3 is all about how elements combine. So, well, that's kind of interesting. Elements combine. Why do elements combine? Like we're looking here, our first section is on electron arrangements and the octet rule. Why do we care how electrons are arranged in an atom? What difference does it make? All atoms want to be stable. So how do you get a stable atom? It's all about electron configurations. So if you have an atom that's on the periodic table and it has an unstable electron configuration, it's going to do whatever it needs to do to get a stable electron configuration. How do we do that? How do we get a stable electron configuration? What can we do? It's all about electrons, right? So you have this set amount of electrons and it's unstable. So what could you do? You could give some up. You can take some. So you could give / take electrons, right? So this chapter is all about compounds, how atoms change their electron configuration to make compounds. So if I give or take electrons, I'm going to make a compound. Anybody know what that is? You watched the lecture. If I give or take electrons, we talked about this before, I turn into a what? An ion, right? I become charged. But it's not just me, right? If I gave up an electron had to go somewhere. So somebody had to take it, right? Some atom had to take it. So now I'm participating in an ionic compound or an ionic bond with another atom. That's where we get the term ionic compound. I know you've heard that before, right? Maybe you just didn't realize, why do we call it an ionic compound, right? Because you become an ion to make it. Okay, what else could I do to get a stable electron configuration? I could give or take as one other option. I could share electrons. Now, these electrons that I'm talking about here, am I going to give up or take electrons from the entire atom? No. There are particular kind of electrons in the atom that I want to give or take or share. What do we call those? Valence. And these are electrons that are in the outermost energy level. Right? So I'm going to give or take valence electrons. I'm going to share valence electrons. That's why I do the VE. VE is valence. So if I share valence electrons, what am I called? Co, like if you're co-captains, you share the captain. So here we're going to be covalent compounds. Why do we call them covalent? Because you're sharing valence electrons. Kind of cool, right? Now you know where those terms come from. All right, so in order to understand how ionic compounds form and how covalent compounds form, we have to understand how electrons are arranged in neutral atoms. Then we can start to give and take and share and all that. But we got to first look at neutral atoms. So when we look at the principal energy levels inside of an atom, what's a principal energy level? It's basically how far away your electrons are from the nucleus, right? And that first principal energy level, they're pretty close, right? Think about like if you're going to a concert, right? And the tickets get more expensive as you go up, right? Because you're getting farther away from the stage. Same thing with electrons. The electrons that are in that first principal energy level, they're really low energy. They're cheap. Now, as you keep going, now they're not cheap, they're expensive, right? Because you're sitting in the front, but they're low energy. Then you move out to the next level, right? Your pay goes down a little bit. So that's the next energy level. The next energy level is a little bit farther away from the nucleus, and a little bit farther, and a little bit farther, and a little bit farther, right? That's what principal energy levels are. But the energy levels are not equivalent. They can hold different numbers of electrons. How do we know which principal energy level holds however many electrons? There's a formula for it. Anybody remember? 2n squared, right? So in our first principal energy level, how many valence electrons can I hold? Put a 1, so 1 squared times 2 is what? 1 squared is 1, and then 1 times 2 is 2, right? Okay, how about in my second principal energy level? So put a 2 in there. I don't know if I'll be able to squeeze it in, but 2 squared times 2 is 8. Okay, how about the third? The third's what? 18, right? So you see how we're going to keep going up and up and up and up in our principal energy levels. Now, the weird thing when you get to the third one is that the arrangement of the electrons, where they want to go first, second, and third, get kind of crazy. And so we'll talk about why that is. So let's look at 3.2. Let's do a very simple atom. Let's look at hydrogen. So find hydrogen on the periodic table. What is the total number of electrons? How do I figure that out? In a neutral atom, right? The number of protons is equal to number of electrons. So all I have to do is find out my number of protons, and I know my number of electrons if it's neutral. So how many in hydrogen? Only 1. So where does that 1 electron go? It goes into the first principal energy level, right? Now, I can look at the periodic table and know that, because what corresponds to my principal energy level, my highest principal energy level in an atom, is the period. So what period is hydrogen in? 1. Periods go across. Groups go up and down, right? Remember that? Okay, so fluorine. How many electrons in fluorine? There are 9. Before you even start filing electrons away, what period is fluorine in? Period, go across. 2. It's in period 2. So which is going to be my highest principal energy level? 2. So how many electrons can I actually fit into that first principal energy level? 2. How many go into the second? 9 minus 2, how many do I have left? 7. So long as I don't go over the maximum, they can all fit, right? Okay. Argon. How many electrons in argon? 18. What period is argon in? 3. Okay, so that's kind of where I'm going to end up, right? Okay, so how many of those 18 electrons go in the first principal energy level? 2. How many go in the second? 8. How many go in the third? 8. And then I get my total of 18. Not too bad, right? Okay. K, potassium. What happened before you do that? Look at the periodic table. Everybody look at a periodic table. When I go from argon, argon has how many electrons? 18. Go 1 more. What element am I? Potassium, right? K. All I did was add 1 more electron. And now what principal energy level am I in? I'm in 4. So we're going to do 19, 2 in the first. We're going to put 8 in the second. We're going to put 8 in the third. Now, the reason why we don't go up to 18 here in the third is because some of those are going into an orbital that's actually lower energy. And so we're going to put that last one in the fourth principal energy level. So how did you know that? What do you have to look at? The period. You look at the period that it's in. And I know my last electron, because we're in period 4, right? We're in period 4. Okay. So you don't have to memorize all the crazy rules. You just kind of have to look at the periodic table. The periodic table's amazing. Okay. So now, we just said a few minutes ago that all covalent compounds, all ionic compounds have to do with movement of valence electrons. Those electrons are in the outermost principal energy level. So look at potassium. Let's scroll back up. Look at potassium. How many electrons are in the outer energy level, the highest energy level? 1. I have 1 valence electron. How many are in argon? 8. How many are in fluorine? 7. How many are in hydrogen? 1. Those that I've circled are all the valence electrons. Now, what can you look at just on the periodic table and know that without having to fill this little chart out every time? The group. So what group is hydrogen in? Group 1. So we have 1 valence electron. What group is fluorine in? 17 or 7A. So that's where the 7 comes from. That's why we like to use those A and B's. It just makes that easier. So we have 7 valence electrons there. How about argon? What group? 18 or 8A. So I have 8 valence electrons. Potassium. I have 1 valence electron. It must be in group 1, right? So we're really just worried about these valence electrons. So valence electrons you can determine by knowing the group number, right? Period tells you the energy level of your valence electrons, okay? That's what those 2 things tell you. We good on that? All right. So pick any element you want. Carbon. What group is carbon in? Group 14 or 4A. So how many valence electrons must it have? Super easy. Aluminum. Group 13 or group 3A. How do I know they're A's and B's? Which ones are B's? The transition metals. So see how you drop down in period 4, starting in group 3 on the periodic table here? That's actually the B's, okay? So 13, 1, 2, 13 through 18 are the A's. Okay, so aluminum, how many valence electrons? 3. Lithium, what group? Group 1 or 1A. How many valence electrons? 1 valence electron. Fluorine. Group 17 or 7A. How many valence electrons? Nice, right? Y'all got this. Man, y'all are rocking and rolling right from the beginning. I love it. All right. So now the question becomes, I just said that atoms want to be stable. What makes an atom stable? Most of the time, 8 valence electrons makes an atom stable. So usually 8 valence electrons, and we call that the what? Octet rule. Usually 8, but there are exceptions. So as long as your outermost principal energy level is full, you're happy. you're stable. So look at hydrogen. How many valence electrons does hydrogen have? 1. How many can fit in that principal energy level? 2. So hydrogen is not stable. Hydrogen is insanely explosive. Insanely. Okay. Very, very explosive. Helium. How many electrons? 2. Does it satisfy the octet rule? Not really, right? Because octet means 8, but it does have a filled outer energy level. We use helium all the time for what? Balloons. It's not, trust me, it's not that flammable if we're using it in balloons at kids' parties, right? So it's very stable. What do we call all those elements that are in group 18? The noble gases. They are noble gases because they're very stable. They all have complete outer valence shells. They all have complete octets. So what I like to do is I like to call those the cool kids, right? Everybody wants to be like the cool kids. Everybody wants a complete octet just like the noble gases. So they will gain and lose and share electrons in order to make themselves look like the noble gases because they're the cool kids, right? Okay, so which of the following elements are stable as atoms? Be is beryllium. How many valence electrons does it have? 2. Now, I just said sometimes if you have 2 valence electrons, you're happy. Is beryllium happy with 2? Why not? Because it's in the second energy level. How many do we need to get to in the second energy level to be happy? 8. We need to get to 8. So is beryllium happy with 2? It's absolutely not. It's so sad. All right. Argon, Ar. How many valence electrons? 8 valence electrons. Is it happy? Stable, very stable. I know I like to give the elements personalities. They don't really have them, but I like it. Okay, fluorine. Fluorine has 7 valence electrons. Fluorine is highly reactive because it's not happy. It wants to become like a noble gas. It's so close to becoming like a noble gas. It's very reactive. So is fluorine stable? No, the opposite of being stable is being reactive. So fluorine is not stable. Xenon, Xe. 8 valence electrons. Stable or unstable? Stable. Yay. So xenon and argon. What are these both? All right. So we just said that there were 2 ways to get that complete octet. We can either gain or lose, or we can share. So let's talk about gain or lose first. If we're going to gain or lose, what are we going to be called? Gain or lose electrons, what are we called? Gain, lose electrons. You're going to be an ion. Okay. So I want to review 3.7. What's the difference between a metal atom and its cation? A metal atom is going to lose electrons. Now let's talk about why that is. An octet is 8 valence electrons, right? I want you to think about all the elements as being, they want to be stable, they want to be like the cool kids, but they're lazy. They are lazy because they are going to take the shortest route possible to look like a noble gas. So if I pick a metal, let me pick lithium. Find lithium on the periodic table. How many valence electrons does lithium have? 1. So lithium has a choice. Lithium can either gain 7 valence electrons to look like neon, or what else could it do? Lose 1, and then what's it going to look like? What? Helium. It's going to look like helium. Well, they're lazy, so what are they going to do? Lose 1, because it's easier. So metals that are on the left side of the periodic table, it's easier for them to lose electrons. So they're going to become cations. Because if you have an equal number of, let's do lithium. I'm just going to do it here and I'll erase it. So lithium has 3 electrons. And of those 3 electrons, it has 1 valence electron, right? What else does lithium have? 3 protons, right? Because that's what makes it neutral. That's what makes it an atom. Now, if I make the lithium ion, I'm going to lose this 1 valence electron. So I go from being lithium atom to losing 1 valence electron. So now I have 2 electrons total, and I have 3 protons. So I have 2 negative charges and I have 3 positive charges. What's my overall charge? +1. So then we put a little plus, and that's how we know that we have a lithium ion. Okay, so those are metals. All right, let me erase. Now let's talk about nonmetals. Okay, so nonmetals. What's the difference between a nonmetal atom and its anion? So if you have a nonmetal, see, this is what I don't like. I want this. Nonmetal. Oh, it was NON, nonmetal, y'all. A nonmetal is always going to have the same number of what? Protons and electrons. Okay, so let's pick one. Let's pick fluorine. Pick it on poor fluorine. Tell me about fluorine. How many electrons? 9 electrons. How many of those are valence? 7 valence electrons, okay. And how many protons? 9 protons. Okay. If fluorine becomes an ion, what's it going to do? Gain or lose? It's going to gain electrons. So fluorine's at 7. If it gains 1, it looks like neon. If it loses 7, it looks like helium. Easiest way to go. What do? Gain 1, right? Okay, so if I gain 1 electron, now I'm an ion and I have 10 electrons and I have 9 protons. So I have 10 negative charges and I have 10 positive charges. Oh, I do not have 10 positive charges. How many positive charges do I have? 9. So I have a total of how many? Total charge of -1. So I'm going to put a little negative sign by fluorine. That's how I know it's the ion. So typically, nonmetals are going to become what? Anions. They're going to become anions. Okay, so an anion has a net negative charge. Okay. So when you name them, if we say it's an atom, no matter if it's a nonmetal or a metal, we just say the element name. So if it's fluorine, it's fluorine, right? But when we convert that fluorine into an ion, instead of calling it fluorine, we're going to call it fluoride. Okay, so that's for, this is for nonmetals. How about metals? The atom, what do we say? Element name. How about the cation? We say the element, and then we say ion. So we say potassium ion, lithium ion, beryllium ion. Okay, that's how you name them differently. Okay, now we got the troublemakers. The troublemakers are those transition elements. So we have to name transition metals differently. And the reason that we have to do that is because transition metals can carry more than one charge. Okay. So you have one element on the periodic table, like, what is Fe? Fe is iron. So iron could be a +2. Iron could be a +4. So if I just say the iron ion, which one is it? Do you have any idea? No. So how do we indicate what the charge is on the ion? We use Roman numerals. So you use Roman numerals after the element name. So you would say iron 2 ion, or you would say iron 4 ion. So you know how to do 4? It's the subtraction IV is 4, whereas VI is 6. Yeah, and then you just say ion. So make sure you put those Roman numerals in parentheses. Okay. Good on that? All right. Okay. Provide the charge when an ion is formed from each of the following. Sodium, what's the symbol for sodium? Na. Okay. And what's my charge? I'm in group what? Group 1. So I have 1 valence electron. So that means I have 1 valence electron. What am I going to do? Do I want to gain 7 or do I want to lose 1? I'm going to lose 1. What happens? If I lose 1 electron, I lose a negative charge. I'm going to become positive. So it'll have a charge of +1. So how do we write that symbol? We write Na and then a plus. We just know that the 1 is understood. If you need to write this out the way that I've written it out, please do it. Sometimes, you know, you're just like thinking in circles. So sometimes writing it down really, really helps. Okay, phosphorus. What's the symbol for phosphorus? P. What group? We're in 5 or 5A or 15. So how many valence electrons? 5 valence electrons. What's going to happen if I have 5 valence electrons? Do I want to lose them? No, I want to gain. It's easier to gain. How many am I going to gain? Gain 3 valence electrons. If I gain 3 electrons, I'm gaining 3 negatively charged particles. What's my now charge? I was neutral before. What's my charge now? -3. So how do I write that symbol? P, and we put 3 minus. I know it's weird that the minus sign comes after the number, but that's the notation. But I know it's kind of weird. Okay, magnesium. What's my symbol? Mg. What group? I'm in group 2A or group 2, however you want to say that. How many valence electrons? 2 valence electrons. What am I going to do with those 2? I'm going to lose them. What does my charge become? +2. So what's my symbol? Mg2+. Okay. Now I'm going to take a little side trip real quick to the periodic table. Y'all ready? Okay. I don't want you to, I want you to recognize this, but I don't want you to write this on your best friend because it's not, this is your best friend as you're going to get it on the exam, right? So if you write all over your best friend, just remember that all that writing you won't have when you get to the exam. So basically everything in group 1 is going to do what? It has one valence electron. It's going to lose that one valence electron. It's going to be a charge of +1, right? How about in group 2? What are we going to be? +2, right? We're going to say that these are going to vary, right? But they're all going to be positive. They're going to be positive. Okay. And I'll show you how to figure out those later. Group 3. Easier to lose 3 or to gain 5? Lose 3. If I lose 3 negatively charged particles, what am I? +3. Okay, group 4, they like to share more than they like to gain or lose because you're at 4, right? You don't really want to give them up. You don't really want to take them away. So you kind of end up being more covalent interactions. So how about 5A? If I have 5 valence electrons, I want to gain 3, so I'll have a charge of. How about group 6A? How about group 7A? How about group 8A? They don't form ions because they are the cool kids, right? They don't need to. So you can just look at the periodic table and know how many valence electrons, right? But if you write this on your best friend, know that you cannot go into the exam with that information, okay? All right. Let's see, where were we? Here? No, we had gotten farther. Oh, fluorine, we missed fluorine. Okay, what's the symbol for fluorine? F, what's it in? Group 7A or 17, how many valence electrons? What's it gonna do? 1. It's gonna be a charge of -1. So we just put F and then we put a minus sign because a 1's understood. Okay. All right, now we're going to go the opposite direction. I'm giving you the symbol. You need to tell me how many protons and how many electrons are present for each of these. Okay, so this is going to be our P plus, E minus. So aluminum. How many protons in aluminum? 13. Now, in a neutral atom of aluminum, how many electrons? 13. But I have a charge of +3. So what is that charge of +3 telling me? What have I done with aluminum? Am I gaining electrons or losing electrons? I'm in group 13. I have 3 valence electrons, so I'm going to lose those 3. So I'm going to lose 3 electrons, and I'm going to have how many? 10. So if I have 13 positive charges, so if I have +13 and I have -10, what's my charge? +3. And that's where we get this +3 right here. Okay. This is kind of backwards, but stick with it. Okay, bromine, how many protons? 35. So bromine normally has 35. How many valence electrons does it have? 7. So what's it going to do? It's going to gain 1. So I put a +1. What do I get? 36. Double check your math. I have positive 35. I have negative 36. What do I get? -1. And that matches. So you can always check your work. Okay, mercury, Hg. How many protons? It's kind of in the middle. It's the blue one because it's a liquid at room temperature. 80. So I have 80 electrons. Now it's the ion. Now, because it's a transition metal, you can't know right away what's going to happen. You have to look at the charge. So if it has a charge of +1, what does that mean? It has lost 1 electron. So what do we have? 79. So check that. I have positive 80, negative 79, charge of +1. Okay, N3 minus. How many in nitrogen? How many protons? 7. How many electrons? 7. Now, how many valence electrons? 5. I'm going to lose 5 or gain 3. I'm going to gain 3. So I put a plus. I'm going to gain 3. How many do I have? 10. So let me check. I have a positive 7. I have a negative 10. I get a charge of negative 3. Good. Okay. All right. Now we need to name them. Al 3 minus, 3 minus, 3 plus. What do we call this one? It's a cation. So what do? We just say aluminum ion. Okay, Br minus. This is a anion. So what do we do with anions? We change the end to IDE. So this is bromide. Bromide, bromide. Okay, mercury. What should we name this one? Mercury ion. We good? Why not? What are we missing? Roman numerals, because mercury is a transition metal, so we have to put the charge in Roman numerals. So it's the mercury 1 ion. Okay, N3 minus, what should we call this one? It's an anion. So I'm going to call this one nitride. Like I tried, but nitride. Okay. All right. 3.20. Name the following ions. Cu2 plus, excuse me, Cu2 plus. What do we name it? Copper 2 ion. And I think in your homework system, make sure you use no capital letters when you write out the names. So for the names, no capital letters. Leave everything lowercase. Okay. All right. Oh, this is tricky. What is this? What is SO? SO4 2 minus. S is sulfur, O is oxygen. So this is an example, B and C are both examples of polyatomic, right? Poly meaning more than one, atomic meaning atom, more than one atom, polyatomic ion. So it's more than one atom that carries a charge. Guess what? Your best friend just got better. Right? Why did your best friend just get better? Because I have a polyatomic ion chart for you. Do you have to memorize all your polyatomic ions? No, no. If it's not on here, I'll give it to you. Okay? So go and find, use your best friend. Go find SO4 2 minus. What is that? Sulfate. Tell me, what is the difference between sulfate? This is sulfate, SO4 2 minus. What is sulfide? Give me the symbol for sulfide. It's just sulfur. And then you have to find a charge, which is 2 minus. Because you gain 2 electrons. So be careful with some of these that you have to really pay attention to the ending, okay? Just be really careful with that. All right, HPO4 2 minus. Go to your best friend. What is HPO4 2 minus? Hydrogen phosphate. Okay. And there are all kind of naming rules for how you know if it ends in ATE and ITE and IDE, and we'll get there eventually. Okay. All right. So now we're going to not only name ions, now we're going to have ions that interact with other atoms that become ions, and we're going to make compounds. Aren't you so excited today? We get to make ionic compounds. It's awesome. Like, no, you're crazy. Okay, so potassium. If you go and look up potassium on the periodic table, if it forms an ion, it wants to form the most stable thing that it can. So go and find potassium. What kind of an ion, excuse me, does potassium make? Just like what we've been doing before. What's the charge? +1. I just didn't hear anybody. I didn't hear anything. Okay, that's potassium. Now, potassium and chloride, that's telling me it's an ion. So what's my charge on Oh, what? Is Zoom still going? That was really weird. Y'all on Zoom, y'all can still hear me and everything? Hopefully somebody says yes. Yes, okay, yay, thank you so much. Okay. So chlorine, good, thank y'all. So chlorine, what kind of a charge does chlorine carry when it's an ion? -1. Okay. What does that tell me about potassium? What has potassium done? It lost what? 1 electron, 1 valence electron. What did chlorine do? It gained 1 electron. So basically, can you tell me what happened? Potassium gave chlorine a valence electron. Now they both have complete octets, right? So it was a 1 for 1. Doesn't always happen that way, but in this case, it was a 1 for 1. So in order to make this compound, how many atoms of potassium do I need and how many atoms of chlorine do I need? 1 of each, right? Because it's just a handoff. So when I write my formula as KCl. So if I have nothing written as a subscript, how many atoms do I have of each? Only 1, right? Instead of writing this K1, Cl1, right? I just write KCl. So we don't do that. We just write KCl. Okay. Now let's look at zinc oxide. Zinc. What charge does the ion of zinc carry? Now, where do you find it on the periodic table? Transition metal, but I'm going to give you a trick. Okay, when you look at the periodic table, do you see aluminum? What's the charge on aluminum? +3. If you go on the diagonal, these 3 elements go +3, +2, +1, and they don't vary. So it's a little trick to remember those transition metals that only have 1 charge. And so therefore we do not write a Roman numeral with them, and we always know what charge they have. So it goes 3, 2, 1 on that diagonal. Okay. So make sure you jot that down. Okay. And let's go back. So zinc, even though it's a transition metal, I know right away it must be a charge of +2 or 2+. oxide, charge of what? Negative, it's group 16, so it could lose 6 or gain 2. What's it going to do? It's going to gain 2 for a charge of, minus 2. So zinc over here is going to lose what? 2 electrons. Oxygen over here is going to gain 2 electrons. So what happened? Zinc gave oxygen 2 electrons. So we need only 1 atom of zinc for every 1 atom of oxygen. So how do I write the formula for that? ZnO. Right? Now, I'm going to show you a trick. You could logic it out like that every time, or you could do the trick. I love tricks. Don't y'all love tricks? Okay. So if I'm going to do KCl, K plus, Cl minus, what I do is I do the crossover trick. So this is really a plus what? This is really a minus 1. Okay. So what I want you to do is take the charge on one and make it the subscript on the other. And then do the same thing. Take the charge on the anion, make it the subscript for the cation. So what do I get? K1, Cl1, but do I write the ones? No, so it's KCl. Right? The same thing would work with our zinc oxide. So if we come down here and we do this one, right? So we have Zn, that's a +2. We have O, that's a -2. So what we want to do is we want to do that crossover, and we're going to take the charge on the cation and make it the subscript for the anion. So that's a 2. Then we take the charge on the anion, make it the subscript of the cation. So Zn2O2. Now wait, that's different than what we got. Why is that? It's the same thing. It's like balancing a chemical equation and reducing all of your coefficients. You reduce subscripts as well. A 2-to-2 ratio is the same thing as a 1-to-1. So you just reduce it and you get ZnO. That trick will work every time. Call that the crossover trick. Okay, so let's try some more. All right. Oh, did I answer everything it asked for? Give the formula, oh, and the name. We have to name it. I forgot, we didn't name it. Okay, so let's go back and let's name them. KCl. How do we name KCl? If it's the anion, if it's the cation, potassium's the cation, that's the plus. How do we name it? Just the name, potassium, right? Not a transition metal, so we don't need to put Roman numerals. And then what about Cl? It's an anion, so we change the N to IDE. So it should be chloride. Chloride, potassium chloride. Good. All right, so let's do this zinc one over here. So what do we call, what do we say for zinc? We just say zinc. Now, do we need a Roman numeral? It is a transition metal, but we don't need a Roman numeral because zinc and silver are on that diagonal and we know what they are. So we never have to write a Roman numeral for those two. Okay, so what do we call this? Zinc oxide. O-X-I-D-E. I could spell. Oh, I think I have to do it here now to make it green. I-D-E, oxide. Okay. All right, let's see. Oh, and we forgot C. We didn't do C. Okay, copper 1 and sulfide. Let's do this color. Copper 1. What is copper 1? Is it CO? It's Cu. Copper is Cu. And what's the charge on it? +1, so we just write a plus, right? And then sulfide, I'm crammed. I'm going to do this, Cu, and it's a plus. Okay, and then the sulfide, what do we say? Sulfur is the element. It's in group 16, so it has 6 valence electrons. It's going to gain 2, so it's going to be 2 minus. Do your crossover, right? So where we have a 1 here, let's do that. Where we have a 1 here, it's going to go down here. And then where we have a 2 here, it's going to go down here. So when I rewrite this, I get Cu2S. We just leave it. And does that make sense? Copper is going to give 1 electron to sulfur, but is sulfur going to be happy? No, sulfur needs 2. So how am I going to give sulfur another electron? I need another copper atom. So I have 2 copper atoms. Each copper atom is donating 1 electron to sulfur. Sulfur has gained 2 electrons. Cool, right? But it is, it's amazing. All right, 3.24, potassium and chloride, the main ingredients in salt substitutes. Didn't we just do this? Oh, this is a different thing. It's give the number of each type of ion present. So if we do potassium and chloride, what did we say the symbol was? KCl, right? That's our formula. Oh, did we name? We didn't name this guy. Y'all. Here, this one, because here we had to name it. Copper 1 and sulfide, right? We had to give the formula and the name. So what's the name of this one? Copper 2 sulfide. Sorry, I'm jumping around, y'all. Okay, now we do the same problems, but in this case, we're going to give the number of each type of ion. So for our potassium ion, K plus, how many do we have? 1. And our Cl minus, how many do we have? 1. Okay. Zinc oxide, we said up here we had ZnO. What do we have? Zinc, what's the charge on zinc? +2. How many do we have? Look at the formula. If there's no subscript, it's just 1. So we have 1 ion. An oxide, oh, I wasn't spelling it, but which is O2 minus. How many do we have? Only 1, right? Because zinc gave up 2 electrons to 1 oxygen atom. So 1 zinc atom gave up 2 electrons to 1 oxygen atom. Now they're both happy. Okay, how about C? We said Cu2S. How many ions of Cu do we have? We have 2 ions. And how many of sulfur? S2 minus. 1 ion. And that makes sense, right? Because it took 2 copper ions, each giving up 1 electron to the 1 sulfur atom for sulfur to be happy. It's all about a ratio and how many electrons are being given. Okay. All right. Repeat 3.25. What was 3.25? What were we supposed to do? Supposed to formula and name. Okay. So here we're doing formula and name. Okay. So we're going to do it, but we're going to do this with the acetate ion. So if we have sodium, what's the charge on sodium? Group 1, so it must be +1 or just plus, doesn't matter. Okay, and then the acetate ion, C2H3O2 minus. That means that all of these atoms put together have a charge of -1. Okay, so now I need to write the formula and name it. What do I do? The quick and easy way is to do the crossover, right? Now, if you have a polyatomic ion, that's what acetate is. When we write the new formula, we're going to put it in parentheses because we don't want to mess with any of these blue subscripts. They have to stay the same. And then we're going to do the same thing. We're going to cross over here. And that's really a -1. So when I rewrite it, how do I rewrite my formula? Na, but there's only one, so I don't have to write anything. And then I only have one, so I really don't have to write anything. So really, it's this, C2H3O2, 1. But because we don't write ones, what we really write is just this, C2H3O2. So you don't actually need the parentheses as long as you only have one of them. See if I can extend the page. Okay, we're going to do the same thing, except this time we're going to use iron. So B is Fe2. So Fe2, how do we write that? Fe2+, right? Now we're going to add the acetate ion to that. So we have C2H3O2 minus. And that's just like having a minus what? -1. Okay, so let's do the crossover. Take the charge and make it a subscript. Do the same thing, take the charge, make it a subscript, and you drop the positives and negatives. So now how do we write the formula? Fe, let me extend the page. Fe, and there's a 1, but we don't write the 1. Open parentheses, C2H3O2, that's the polyatomic ion, close parentheses. Now this red 2 is now that 2. So for every 1 iron ion, we have 2 acetate ions. So how do we name this? Iron, the Roman numeral comes from the charge. So this is iron 2 acetate. It's not telling you how many atoms of iron you have. It's telling you the charge of the iron. That makes sense? Be careful, be very careful with that. And I think did we name A? We didn't name A. How would we name A? Sodium acetate. Okay. Then we got to go and get the last one, C, aluminum. Oh, okay, so C is aluminum. What's my charge on aluminum? 3+, and then I'm adding it to acetate. So what's my formula for acetate? C2H3O2, and what's my charge? -1. So I'm going to do my crossover. I'm going to take my charge on 1, make it my subscript, and then I'm going to take the charge on the other and make it the subscript. But drop that charge, drop that plus and minus. Okay, so I rewrite it. What do I get? Al, but do we write the 1? No. Then we write our whole polyatomic ion of acetate. We close parentheses, and then we write that red 2. So how many ions of aluminum do I have? Oh, it's a 3. 3. Sorry, y'all. It's a 3. I've been stuck on the 2s. Thank you. It's a 3. Okay, so how many ions of aluminum do I have? 1. How many ions of acetate do I have? 3. So one acetate ion can only give up 1 electron, but aluminum needs 3. So how many acetate ions do we need? 3. Crossover is awesome. Just don't do that mistake that I just did. Right? Okay, that was the end of the page, right? Okay. Okay, so for the same one that we did, for this last one, it says give the number of each type of ion present. Well, we already kind of did this. So let me go back and do that. We'll just do it here. So how many sodium ions? It's the answer to 3.28, but we're using the problems from 3.26. So sodium ion, I have 1. Acetate ion, I have 1. Okay. In B, I have the iron ion, iron 2 ion. How many? 1. Acetate ion. 2. Okay. And then C, aluminum ion. How many? 1. Acetate ion. Okay. Good. Yay. All right. And that's it. Because you didn't have to watch 3.4 yet. That's it. We're done early. Time is it? Oh my God, that never happens. Y'all have questions before you run out? This is, now listen, this lesson today is critical to like everything we do for the rest of the semester. So if you didn't get it, or if you are struggling with it, please stay and let me help you with it. Okay? Otherwise, don't forget iClicker on Tuesday. So make sure you have an iClicker device or your phone, whatever it is, so that you can use it on Tuesday. Y'all have a great weekend. Go watch some videos. It was good to see you all. Anybody on Zoom need anything? Let me see if Zoom needs anything, and then I'm going to answer. So is everybody okay on Zoom? Let me see. I still have a few people there. Any questions on Zoom? Nope. Okay. I'm going to end the